Hello, this has just arrived for me to fix, and it's a Cambridge, R Cambridge A60 amplifier, and it's from one of my YouTube viewers who saw me do a repair on a similar model to this. The one I worked on before was an earlier model. This is a later version with slightly different circuitry in it. And what can we say to start with? He told me that the top is not screwed on because there are no brackets. There should be some metal brackets that come down. Fine. He gave me an Allen key to take the knobs off. It's very good of him. Well, I probably got one the right size. I put the cut top over there, and as this is a later model than the one I did before, they have improved the design by using LM317s and 337s. Another one down there. In the low voltage power supply, plus or minus 15, so that's saves a lot of circuitry trying to do it in discrete components. So looking in it, I don't really see anything obvious to start with, so guess I could plug it in, turn it on. He said it was very distorted and volume was low, I think. So yeah, let's plug it in. No speakers connected at the moment. Okay, turn it on. LED comes on. That's something. So before I connect anything up to it, what I need to do is check the speaker outputs. I could check the power supplies, I guess. But the meter, I think it'd be alright there. So we've got some main filter capacitors on the power supply. There'll be 0 volts in the middle. There should be around 35 volts, I think. .35 volts positive. So I guess this must be negative. No. What am I doing wrong here? I would have thought that was the negative. It should be negative. It's got negative written on the capacitor. Well, that's not much good, is it? Let me investigate. Okay, found out what the problem was. The meter was set wrong, and I believe that's a common earth point where that screw is. So this is the negative side. Oh, it would be if I turned it on. Minus 35. Okay, that's good. Minus 30, plus 35. Good. So we got DC there, and where are the regulators? Those are the regulators. So that's an earth. That should, I think that should be 50, minus 15. Okay, that's good. And The other regulator's down here, plus 15. So that's good. That supplied, those 15 volts are for the pre-amplifier stage. So what have we got on the circuit, which I printed out earlier? Power amplifiers. No, that's the power supply. Okay, so this is the main power amplifier circuit for one channel, and they have incoming fuses from those capacitors, I believe. So let's check. That'll be those two there. Back to the earth point. Minus 35. That's good. Plus 35 on the other side. Minus 35. Nothing. Okay. So this looks like we've got a blown fuse for a start. Not even any point in checking the speakers terminals to see if there's any voltage on them. Well, I can do. There may be all sorts of strange things on there. Let's go to that one again. Yeah, I got minus 2 volts on there, you see. That's a warning there, is never to connect speakers up. Minus 2 volts on the other one. I don't think it would have damaged my speakers, but certainly not a good idea to stick DC up them. So what do we do now then? Well, I could replace the fuse, but I don't think that's a good idea, because somebody's caused that to go. So what I am going to do, and what I have done before, is rather than run it on AC, which is basically no current limiting, I can stick my power supply across the rails, plus or minus 30 volts I can go up to. That is good enough. And I believe the quiescent current is around 100 milliamps, but I suspect it will be more than that. So let me rig up my power supply. So I set the power supply 31 volts, well, roughly on both channels, and the current limiting at 250 milliamps. And as you can see here, that's your earth wire, that's your negative voltage and positive. Now if I switch on the power supply, well, what have we got? Well, that doesn't seem too bad. 40 milliamps on the positive channel, 82 milliamps on the negative channel. Right. So, I've just realised the fatal error. Of course, I have to go on. Let's turn them off again. Silly me. I have to go on the other side of the fuse, don't I? The other side of the fuse. Right, let's try again. No, that's not so good. Positive rail dropping down to 0.6 volts and it's drawing the full current. So I could turn that current limiting up and something would probably get very hot eventually. So we have a short, and what were my immediate suspicions? Possibly the output transistors, which are on the back there. Maybe I'm jumping to conclusions, but but the fact that I've only got 0.6 volts means I probably won't feel any heat. So I think the best thing to do with it is get it out of its box, which means disconnecting all the wiring. They're not too hard to get apart, if I remember rightly. I'm actually surprised he got anything out of it. He said it was quiet and distorted. Okay. So, turn the power supplies off and get it out of its box. Well, as I was disassembling it and trying to take this piece of aluminium off from the heatsink, I noticed something odd. It looks like tape, ordinary duct tape being used as an insulator. But there again, there are some what looks like proper insulators underneath. But if I check the resistance between that and that, that's 0.3 ohms. That doesn't sound good, does it? That one's 400 and something ohms. That's next one, 0.4 ohms. Don't know about that. So that's the collectors of those power transistors. Collectors. It might not be a problem. It might be there's just a short on the supply. I'll go across the 3.6k. Charging capacitor. I don't know, I have to investigate that further when I've got it all apart. Enough for that for today, I think. So I've taken it out of its where it lives, and this really doesn't look nice at all. I mean, you don't use bloody tape as an insulator, and that's just seal pads of gone low resistance or shorted through. And not only is there a problem that I've discovered, but this is not going to be a very good thermal conductor, this tape. So I think this has been a bodge by somebody, but I don't know for sure. I don't know its history. But what I have done now, what have I done? Yeah, I've disconnected this bracket, so there's no shorts anymore, and I'm ready to power it up again. In order to do that, I put a fuse in there now to replace the blown one. There's a 4 amp fuse, should be a 3.15, but it doesn't matter at the moment. So there we power it up again off my power supply. Well, here we go. Charging up. Okay, 77 milliamps on positives, 80 milliamps, 84 milliamps on negative, which would sound about right for something like this. And they are very mildly warm, the power transistors. It could be, because everything else is cold in here. So maybe I found the fault, maybe I haven't. There's only one way to find out, isn't there? Well, what we can do, we can now check the speaker outputs for any DC. We can put that, let's stand it out properly, shall we? I don't know how to put it, it's so difficult, isn't it? Life. So now we know that this is the common earth, and this is the speaker fuses over here. And we've got nothing on that one. And we've got absolutely nothing on that one. Just a sanity check. 30 volts, that's what I wanted. And negative 30. So it could be working, couldn't it? Who knows? It's probably time to stuff a signal into it and bodge up some connection for the speakers. Okay, well, that's going to be a good one to do. But I think the answer is, if this is the fault, then I'm going to have to find some proper seal pads to replace what's this mess here. Anyway, let's wire it up. Okay, this hideous cobbled up mess is an attempt to power off a power supply and to connect some speakers to it. Power supply ones are there, and the speaker, I've got one on yellow, I've got a common green to earth, which is there, and a red on the other speaker. And I think I'm ready to turn on the power supply again, and that's fine. It's drawing the same as it did before. Now let's turn on some music. I'm going into auxiliary input. Well, I'd say that's working, believe it or not. That was a bit of D-light. Groove is in the heart. As I've got away with it so far, I'm going to play a bit more. Okay, you probably had enough of that. It's quite a decent song. So I appear to I haven't fixed it exactly, but I found the cause of the problem. And they're not even warm, but it's very low volume. And it's actually drawing 103 milliamps on both positive and negative channels now. So that's a good sign. So what I need to do to finish this off and get it back together is to get rid of all this crap and get a decent set of seal pads, because that looks a bit how are you doing? I don't trust it. I mean, there is a bit of blackness. I don't know if that's serious, but it's not very nice anyway, whatever it is. So I need to order that. 4 individual ones I'll order for the transistors, and a fuse if I haven't got one. I mean the 4 amp fuse would probably be fine, but it's probably best to have the right one in there. I might have one if I look hard enough. So I'll get on and do that. Wonder what the music's doing there. Bit of hum. That's probably not unusual. No problem. Hum's just picking up noise off my conductive workbench. I'm not worried about that. And when I've got it all back together, it's going to be a while now till I get all the parts for this. I can do some proper tests on it. Power output and distortion, stuff like that. The usual sort of things I do. Okay, I'll see you in however long it takes to get stuff for this. Okay, well there's a few things I can do while I'm waiting for the new insulators to come. I can give this heatsink aluminium bracket a bit of clean up with isopropyl alcohol. Get all that old heatsink paste off and check. And there's quite a large amount on here. There doesn't need to be any on the side with the seal pad, only on the bit that goes to the heatsink or the case. And it can do more harm than good sometimes if you've got too much of it. It's also got inside the holes for something to push through. And nothing's the right size. Nothing is the right size. What's this like? Yeah, that goes through. This is hideously messy. And what I'm also looking for, that's the wrong size as well. What I'm also looking for when I do this is anything that could have cut through and caused that short circuit. But that feels fairly smooth. I don't think there's a problem with that. And that is now ready more or less for when I get the new pads. Okay, that can go to one side. And of course, it's all over the back of the box. And I'm imagining the actual heatsink is stuck on. No screws. Okay, so that can come off pretty easily. Now it's ready for a new paste to go on. And that's that done. Another thing I could do, because I've got nothing better to do, check these main capacitors. I don't expect them to be bad, but we'll check them anyway. I'm not sure if you should test them in circuit really, but supposed to be 10,000 and 9.5 millifarads, ESR 0.02, that's perfectly fine. And let's check the other one. Move my wires over. No one's got an ESR 0.02 also. No, didn't want to do that. Bloody thing, I've forgotten how to use it half the time. There's a problem I was having with that EEV blog meter earlier. So complicated, I don't know how to use it. That one's measuring 9.6 millifarads. Nothing wrong with those whatsoever, and they're absolutely fine after all these years. I don't know if they've been replaced, but they may have been. But they look good quality. There's a sort of a date code on that one, 4218. So that, yeah, maybe they have been replaced then. Let's have a look underneath. I think there's some evidence from soldering. I think they may have been replaced at some point. I don't know anything about the history of this at all. But don't know about the other capacitors. But I'm not going to go through and check all of those. As long as it works, that's the main thing. And what else am I going to do? I think, although the control sounded absolutely fine, no scratching, I think it's, as it's here, I will spray some switch cleaner in there, into each one. So we've got some brand new service oil, except it's not called service oil anymore, it's called contact, whatever you pronounce that. Switch cleaning lubricant. I wonder if it's the same recipe as the old one. But it's gone up a hell of a lot now. That was, I think, £9 for that. So I'm just going to try and get in these controls. And most of it comes out on the board, of course. We can deal with that later. It's good that they've got holes in there, you can get into them inside. Right. And I suppose I'll have to clean that mess up best I can. Not that it's going to do any damage, I don't think, but as I'm doing it for a customer. Cotton buds, what I need. Anyway, this is fairly boring, you don't want to see this. But the owner might. Quite warm in here today. Temperature is 10 degrees. But looks like it's going to get colder. But sunnier in the next few days, which is quite good because when it's sunny here, even in the winter, warms the house up nicely. Don't need to put the heating on. It's just that the workshop doesn't get much sun on it, so it stays cold. And that'll do for now, I think. Got most of it off the board. There's not much else I can do, I don't think. These switches, I don't know how easy, they're not easy to get into. I'll give them another test, but I think they were fine. Transistors, they need a bit of a clean up with alcohol, which is still, my cloth is still wet. I don't know whether they shouldn't have any paste on here. Paste should be on the, you should be relying on the sill pads. And they're smooth. There's nothing that I can feel that's going to cut through the actual pads. So that's about it. Just gotta wait now till those new pads arrive. Okay, so several days later, new insulators are installed, and yet I'm still getting shorts. But somebody whoever worked on it before had put the wrong plastic insulating screw insulators in, and the screws were shorting out. So a lot of hassle. But now if we check from transistor to heatsink, can't see this, but anyway, it does squeak when you short it. No shorts, no shorts, no shorts, and no shorts. So now I've got to get it back in its box and put some more heat conductive paste on there. So I'll go ahead and do that. I won't film any of that because this video is getting too long. I just want to get on and test it and get it working. So it's all back in its box. I'm still at the moment running it on my external power supply rather than plugging the mains back in, well, the low voltage AC back in, and looks good. 90 milliamps on one side, 88 on the other side, positive and negative rails. Got speakers wired up to it, and I'm putting a signal into it. Also, there was a screw missing out of there, which is near the phono inputs. I thought that was fairly important, so I put another screw in there. Let's turn the volume up then. Just a quick try on some music. Sounds good to me. So I think it's safe to plug this back in there, get my power supply disconnected, and then let it warm up a bit and check the bias. Okay, so it's now running on its internal transformer supply. So that's all working fine. Just leave it for a bit now to warm up and do the bias adjustment. Okay, bias adjustment. Got to measure 8 millivolts across R22 and also across R22. Oh no, what am I talking about? R641, R63, which are 20.22 ohms. Fine, 0.22 ohms. 8 millivolts. This is just for one channel, this particular circuit. So let's get the meter into somewhere where I can see it. Right, I'm on millivolt range. Now these are the 0.22 ohm resistors on one channel, and difficult to get across them. Maybe I can put the meter there. And doesn't much matter which resistor I use, because it's equal current flowing through all of them, both of them. It's on 4.8 millivolts. It's a bit low. It needs to be 8. It needs to settle. I think that's good enough for that side. And the other ones, hope you can see it, are those two. Nice low as well, 3 millivolts, and that'll be the adjustment there, V2. That's going up nicely. Let it drift up a bit. Turn it down a bit. Go let it settle. Could go a little bit higher, but I don't think it matters that much. That I'd say is pretty close. Let's check on the other ones again. On the other channel. That's gone up to 8.3. You have to keep waiting for it to settle, you see. 10.9, that'll do. After all, when these were made, they didn't really have the accuracy of multimeters like we have today. They might have had digital meters, but I doubt whether they had the same resolution as I've got with this one. Because single turn pots don't help. Then I'll leave it at that. That's more or less close enough, I think. Okay, that's the bias done. There's one other thing about this circuit which intrigued me. Where's it gone? If we look at this bit, this is the preamp. See, this is the tone control and preamp bit, bass, treble, and various other bits and pieces, and it feeds out on this balance control here. So I see this FET here. Now I wonder what that FET does, and I think it's clamping that to earth when you turn it on to stop any thumps or whatever, and that actually is fed from this little circuit here, the Q24. It's got all this around it, so I haven't really investigated it thoroughly, but that's what I think's happening anyway. So what am I going to do now? I think what I need to do really is to do some measurements on it, see what power it produces and what its distortion is like. It's supposed to be 40 watts a channel. Distortion is specified at 0.2%, so I'll just connect everything up and do that test. Okay, so it's now wired up to my dummy load over there, and the oscilloscope's over there, and the audio analyzer's up there measuring watts into 8 ohms. So the owner said he was a bit concerned that the balance was not quite right between the two channels. I've got the balance knob set right in the centre, and I'm inputting 1 kHz 1 volt RMS, and I've got 2 traces on there, blue one and yellow one, although it's difficult to see that, but if I turn the volume up, we're coming up now, and they look pretty well matched to me. And he also was concerned that when I pressed the mono button that they were the same as well, and I can't see a lot of difference when you press the mono button. Let's leave it in stereo for now. Not that it makes much difference because the two inputs are connected together anyway. If I crank it right up and take it up to clipping, there's some very slight disparity, but hardly anything I would say. And look at the power meter quickly, 41 watts, seems pretty good. Back it down again and Now I want to switch to distortion on here. Right, at the moment I've got, at a very low volume, I've got 0.2, oh dear, this camera, right, 0.01% roughly, 0.02%. So I'm going to crank it up till I see it start to clip, and I'll tell you what, let's put it back into power. 24 watts, let's take it right up to 40. watts, distortion 0.07. I think that's pretty bloody good. Let's turn it down again before it blows up. Don't like running them flat out like that. I would say that's pretty impressive, considering it was specified at 0.2% distortion. And let's have another quick look on the scope at those two traces. There is a very slight difference, but only when you get close to its maximum power. So I don't think there's anything to worry about with that. So what can I do with it now? Well, I had to tighten the transformer up because that was loose. I think really I'm gonna just take it into the house and try it on my nice speakers in there with a bit more music, as I seem to be able to get away with playing music at the moment. So I'll rewire it in the house. Oh, by the way, the heatsink is warm but not particularly hot, and the aluminium bracket is about the same. And I think I don't like this heatsink. It's too small for an amplifier of this power, but that's the way it is. And you're not going to run it flat out all the time, are you? So let's take it in the house anyway. Okay, I've got it set up in the lounge, a very sunny lounge. Okay, it's my big speakers, and got CD playing. Happens to be the nearest one I could find. House of Pain, Jump Around.
Jump across the ceiling, monks like a bump up. Someone's fucking jump, yo, I bust him in the eye, and then I'll take the pumps up. Feeling funkin', amps in the trunk, and I got more rhymes in the cops that are junkie. Donut shop, sure enough, I got props and the kids on the hill with my mom and my pops. I came to get down, I came to get down. So get down to seat and jump around, jump around, jump around, jump around, jump up and get down.
Okay, well that sounds good to me. Plenty of volume. Sounds good, nice audio quality. And don't know what else to say about it really. It's just a shame that the top doesn't screw down like it should do, because the metal brackets are missing. If the owner's happy to use it like that, that's fine. So I think that's about the end of this very long video. I don't suppose anybody will watch it all the way through, but that's just the way it goes. So thanks for watching, and bye for now.
Jump around.